Okay. So, good afternoon to one and all. In the previous lecture of electrical machine first, we have discussed regarding star delta connection. Before that, we have already discussed regarding that means star star connection as well as delta delta connection. There are different types of connection we have already discussed, and in the last lecture we have discussed the star delta connection. In that, the star delta 1 and star delta 11 we have already discussed. That means primary of the transformer, it can be connected in star. Secondary of the transformer, it can be connected in delta, and the phase shift between LV winding and HV winding, or we can call it as a primary winding and secondary winding, or we can say that the secondary winding, it can be shifted by a primary winding, or secondary phasor, it can be shifted by a primary phasor by 1 and 11. 1 and 11, it is nothing but it is shifted by a plus 30 degree, or it is shifted by a minus 30 degree. That means there is a lagging phase angle for minus 30 degree. There is a leading phase angle for plus 30 degree. Okay. See, this point we have already explained, and also we have seen the some of the advantages, disadvantages, and application of star delta 1 and star delta 11 connection. Okay, so today we will discuss about the next one point, or next one type of transformer connection, is that delta star connection. That means primary of the winding, primary of the transformer, it can be connected in delta, and the secondary of the transformer, it can be connected in star. Again, if there is a phase displacement, we have already discussed regarding phase displacement 0 and 360, 0 and 180. That means 0 and 6 we have discussed. So now today we will discuss about the delta star 1 and delta star 11. That is delta star 1 and delta star 11. That means primary of the transformer, delta star 1. Primary of the transformer, it is connected in delta. Secondary of the transformer, it is connected in star. And the phase displacement between these two, this one represent that the phase displacement between primary and secondary is nothing but minus 30 degree. That is lagging phase displacement, or we can call it as a LV winding of the transformer. It lags behind HV winding by 30 degree angle. Okay, by 30 degree angle. And if it is represented by delta star 11, that means here it is plus 30 degree. So LV winding of the transformer, it can be shifted by HV winding, or it can be connected by a HV winding by plus 30 degree angle. That means it will leads by primary. Okay, that means there is a leading angle and there is a lagging angle. See, these types of connection, what is the advantages and what is the disadvantages, we will discuss in this class also. See, in these types of connection, the primary of the transformer, it can be connected in delta fashion, while the secondary it is connected in a star fashion. Okay, secondary it can be connected, it is in the star fashion. So we know that in case of delta, the phase voltage are equal to that of line voltage, and phase current, it is 1/3 of that is 1/√3 times that of line current. That is, do you know that in case of delta, तुम्हाला delta मध्ये माहिती आहे, I think. So see, in case of delta connection, PL is equals to VPH, that means line voltage is equals to phase voltage, and IL is equals to √3 IPH. If we want to represent in form of IPH, so it is equals to 1/√3 times IL. Okay, that means phase current, it is 1/√3 times that of line current. Okay, and in case of star, that means these are the primary side relation, and in case of secondary side relation, it is connected in star. So for the star connection, line current is equals to phase current, that is IL is equals to IPH, and VL is equals to root 3 VPH, or if we represent in the form of phase voltage, then VPH is equals to 1 upon root 3 times that of VL. Okay, so these are the basic relation you people already know. See, in that the primary it is connected in delta fashion and secondary it is connected in star, and there is a plus 30 degree or there is a minus 30 degree phase shift between secondary phase voltage and the primary phase voltage. Primary phase voltage and secondary phase voltage मध्ये किंवा LV winding and HV winding, in between LV winding and HV winding, or we can call it as a in between HV phasor and LV phasor, there is a either plus 30 degree phase shift, or it may be either a minus 30 degree phase shift, that is 30 degree lagging and 30 degree leading phase displacement. Okay, see, I will show that connection. The connection of delta star 1, it will be shown in this figure. The connection of delta star 1, it will be shown in this figure, and the voltage on the primary and secondary side is also shown on the phasor diagram. Okay, so the phase angle difference between the phase voltage and the high voltage side and low voltage side is minus 30 degree. So minus 30 degree, that means a lagging phase displacement. Lagging phase displacement is nothing but connection for delta 1, delta star 1. That means primary is connected in delta, secondary is connected in star, and the phase displacement, it can be represented by 1. It is nothing but minus 30 degree phase displacement. That is lagging. We can call it as a lagging phase displacement also. All of you understand this? That means this different notation like 1, minus 30, as well as lagging. That means meaning of that is same, but it is representation. One representation is nothing but by using a clock convection. If we represent the angle, instead of representing angle, we are representing a clock convention or a clock method, or we can represent a plus 30 degree or minus 30 degree lagging leading JKSL phase shift. Okay, see, in that connection, suppose the primary winding of the transformer, it can be connected in delta. Do you know that the delta connection, there is a no neutral point, or it can be connected in delta fashion. So this is the one winding, here it is another one winding, and here it is third one winding or tertiary winding. Okay, suppose we have given a supply, or it may be it is connected to supply terminal having an phases A phase, then B phase and C phase. That is, here it is A phase, here it is B phase, and here it is C phase. So voltage between that phase, that is VAB, VBC and VCA. These are the phase voltage. Line voltage, here it is VA, it is the line voltage. Sorry, representation. Line voltage. So line to line voltage, A to C, A to B, and C to B. So it is nothing but VAB voltage. This one is nothing but VAC or VCA voltage, and here it is VBC voltage. So these are the line voltage. Phase voltage representation, it will be like this. Here we represent the phase voltage. Here it is VA, here it is VB, and here it is VC. So these are the phase voltage. In case of delta fashion, or it may be delta connection, line voltage is equals to phase voltage. VL is equals to VPH. So we can write VA is equals to VAB. VC is equals to VAB, or VA is equals to VA is nothing but voltage between these two terminal, and again the voltage between these two terminals is nothing but VAB. So VA is equals to VAB, VB is equals to VBC, and VC is equals to VCA. Okay, that means line voltage is equals to phase voltage in case of delta connection. Now the primary winding of the transformer, it is connected in delta. Primary winding transformer ची delta मध्ये connect केलेले आहे. So suppose for driving or for deriving a phasor diagram, so we taken one of the phasor as a reference phasor. So consider this one of the, we have taken here one reference phasor. इथे एक आपण reference phasor consider करू. So like that this diagram. So see here it is A phase. We have considered here. This one is the A phase, that is VA of primary side. Primary side चं supply voltage, line voltage आणि phase voltage दोन्ही same आहे. Instead of representing VA, I can represent VAB also. So VA, it is the phase voltage on the primary side. Similarly, if there are balanced phasor is there, so that we can write the another three phasor, that is here it is one phase and here it is another one phase, that is VB, and here it is VC. That means VA is equals to VAB, VB is equals to VBC, and VC is equals to VCA. Line voltage and phase voltage काय आहेत same. So see this one we have taken one of the reference phasor. ही जी काय आहे ती आपण reference phasor consider. Now the secondary side of the transformer. So if we joined these, it will make a delta. बघा याचं कनेक्शन केलं की हे डेल्टा मिळेल आपल्याला. Now the secondary side of the transformer, it is connected in star. Okay, secondary side of the transformer, it is connected in star. So this is nothing but delta star connection. So and the phase displacement between the secondary phasor or the phase voltage of LV winding and HV winding, it is 30 degree. It is 30 degree. So see the phase displacement between LV and HV is nothing but 30 degree. The meaning of that, the LV winding, it is lagging behind by a HV winding by an angle 30 degree. So I will draw the clock. Here it is. This one is the clock. This minute hand, it will be act as a HV winding, and here it is one fashion is there, D star 1. That means one is nothing but LV winding is here. Okay. So this LV winding, it will be lags behind by HV winding. How many angle? कितने angle ना lag होता है? हेलो, हाँ कितने एंगल नहीं लैग होता है? Are you present? No. What is the lagging angle? Hello, am I audible? No.
Yes, sir.
How much time required to give reply? What is the angle? Whether LV is lagging or HV is lagging? LV lag होते क्या HV lag होते? Or secondary is lagging or primary is lagging? Give me reply. Whether the LV winding lag behind by HV or HV winding lag behind by LV? Can I take name of individual? No one is giving response. That means what is the meaning of that? Otherwise I will ask one by one. Just simple question. No one is giving. That means you people are just connecting and keeping mobile outside. All of you present, no?
Yes, sir.
But no one is giving response. Whether LV winding is lagging or HV winding is lagging. क्वेश्चन समझतोय का?
LV is lagging.
LV is lagging. So LV is lagging behind by HV winding by an angle 30 degree. Okay. So LV winding transformer ची जी काही LV winding आहे, it will lag behind by HV winding by an angle 30 degree. See, and it is connected in star. So I will draw the star connection of the secondary side. Suppose this is the one phase, this one is the another one phase, and this one is the another one phase. In each there is a balanced phasor, so that each and every phasor having an 120 degree apart, or it may be 120 degree displacement. Here it is VA, here it is VB, and here it is VC. So this is the star connection on the secondary side. I want to draw the phasor diagram of secondary with respect to primary, or I want to draw the phasor diagram of both. See, the voltage VA in the secondary side च जे काय voltage आहे VA, it will lag behind by HV winding by an angle 30 degree. So can I draw here? I will draw in the same phase or same diagram so that you will get understand. This is the voltage VA in the star connected secondary side. Similarly, there is a balanced phasor, so that we can draw another one here. That means this is the voltage VC on the secondary side, and this is the voltage VB on the secondary side. It will lag behind by HV winding by an angle 30 degree. Similarly, B phase of the star connected system, it can be lagging behind by B phase of the delta connected system by an angle 30 degree. Again here it is angle 30 degree. Okay, so this is the phasor diagram. So see, this one is the reference phasor is taken, and it will lag A phase, it will be lag behind by A phase by an angle 30 degree. 30 degree ने काय होतोय? Lag होतोय. So this is the phasor diagram of delta star 1 connection. Phasor diagram of delta star 1 connection. Okay, getting? लक्षात आलं?
Yes, sir.
Okay, now next one connection is that delta star 11. That means primary is connected in delta, secondary is connected in star, and the phase displacement between that is nothing but 30 degree, but it is leading 30 degree. That means, see, if I represent it in the clock convection on the clock method, clock convection वरून जर represent केलं, so it will be like this. See, I will represent the clock convection. That means the here it is. इधर draw करतो. Okay. See, there it is 12 point, or it may be this is the HV winding, and LV is here. So it is at 11 position. That is delta star 11. So see, this is LV winding. So LV, it will leads by HV by an angle 30 degree. That means plus 30 degree phase displacement. Plus 30 degree phase displacement, it can be represented by 11. So the diagram, it will be shown in this figure. Delta star 11, the primary, it can be connected in delta, secondary, it can be connected in star, and also the phasor diagram, it can be drawn. So the phase voltage on the secondary side, it will leads by the phase voltage on the primary side, or the phase voltage on the LV winding and the phase voltage on the HV winding having an plus 30 degree phase displacement. That is LV winding, it leads by HV winding by an angle 30 degree. Okay, baga, see, suppose if we draw the phasor diagram, primary it is connected in delta, secondary it is connected in star. So primary it can be connected in delta. Suppose I have taken one of the reference phasor, एक जर reference phasor consider केला, that is A phase चा, suppose VA is the reference phasor, and I want to draw the star. So see, the phase voltage of secondary winding of A phase, it will leads by primary winding 30 degree. That means suppose this is the VA of the primary winding. I will draw here VA of the secondary winding. Secondary winding चा VA draw करतो. It will be lead. So this is the VA of secondary winding. Similarly, we can draw here it is VC. Similarly, we can draw here it is VB. Okay. So see, it will leads by VA of the primary winding by an angle 30 degrees. So see here it is the diagram, it can be given, that is this is the delta connected primary, this is the star connected secondary, and the phase displacement between these two is nothing but plus 30 degree leading phase displacement, plus 30 degree leading phase displacement. So these are the connection, delta star 1 and the delta star 11, delta star 1 and delta star 11. Okay. What are the advantages and disadvantages? We will see the advantages and disadvantages of this one. But before that, all of you give me response. All of you understand this one connection? Connection लक्षात आलं का हे?
Yes, sir.
Okay. Okay, see, we will discuss regarding what are the advantages and disadvantages of these types of connection. See, the advantages of these types of connection is that the cross sectional area of the winding, it is less at the primary side. Primary winding, it is connected in delta. You people know the primary winding of the transformer, it can be connected in delta. On the primary side, due to it is delta connected winding, the cross sectional area required for the winding, it is less. Okay, cross sectional area required for the winding, it will be less, and used as 3-phase 4-wire secondary side. That means a star connected secondary side. Okay, then second one advantage is that a 3-phase wire system is there. That means secondary side it is 3-phase wire, or secondary side having an 3 phases and 4-wire system. So neutral is available, due to which we can easily use for a 3-phase 4-wire supply. That means for domestic appliances, or it may be for a domestic load. It can be used for a domestic load or the domestic appliances. Okay, domestic appliances साठी किंवा आपण domestic load साठी काय करू शकतो, use करू शकतो. Now next one advantages is that no distortion of secondary voltage. Okay, see, there is a neutral connection in the secondary side, and this due to that neutral connection, the secondary third harmonic component, it will be not present or directly grounded. So there is a no distortion, or it may be no distraction. Supply voltage मध्ये distortion होणार नाही. So this is the one of the advantages. Next one is that handled large unbalanced load. We have already discussed regarding unbalanced load, and if such a system or the such connection it can be used, it will easily handle the large unbalanced load. Okay, it will easily handle the large unbalanced load, can be handled without any difficulty or the without any distraction. Okay, now the grounding isolation between primary and secondary. Primary it is having an connected in delta, secondary it is connected in star. Okay, so there is a no ground present at the primary side. Whether the ground is present at the primary side? प्रायमरी साइडला न्यूट्रल प्रेझेंट आहे का? Whether the neutral it can be present on the primary side? No, because it is delta connected. On the secondary side there is a neutral connection, it will be present. So see, assuming that the neutral of the star connected secondary is grounded, secondary side ची जी काही neutral आहे, स्टार कनेक्शन मुळे मिळणारी जी काही न्यूट्रल आहे, so it will be grounded. and as the load connected phase to neutral or the phase to ground fault produces two equal and opposite current in two phase. Okay, see what will happen. Neutral ground केली and the load it can be connected in phase to neutral. म्हणजे आपला जर सिंगल फेज लोड कनेक्ट केला, फेज टू न्यूट्रल मध्ये जर लोड कनेक्ट केला, or if the phase to ground fault produces, phase to neutral load connect केला किंवा phase to ground LG fault it will be occur. At that situation it will produces a two equal and opposite current in two phases. Remaining those phases मध्ये it will produce equal and opposite current in the primary circuit without any neutral ground current. So in the primary circuit, neutral ground primary मध्ये नाहीये, then also it will produces equal and opposite current in the primary side. So therefore, in a contrast with star-star connection, phase to ground fault or the current unbalance in the secondary circuit will not affect the ground protecting relaying applied to the primary circuit. Okay, so star-star connection मध्ये if there is a phase to ground fault occur, then there is a unbalanced current it will be occur. So due to that unbalanced current, there is some of the relaying equipment it will be required, or some of the relaying equipment it can be affected by the top unbalanced current, but this condition it will be not occur in case of delta star connection. Okay, it will not affect the ground protecting relaying applied. Ground protection साठी जो काही relay apply केलेला आहे त्याला affect करणार नाहीये. Okay, so these features enables proper coordination of protecting device. Okay, so there are multiple protecting device it can be used. That means we use the MCB, whether you use the circuit breaker, whether you we use the some of the relaying equipment. There are multiple protecting relaying equipment. Suppose for earth fault protection, for ground protection, okay, for transmission line protection, for transformer protection, there are multiple types of switchgear equipment it can be used. So relaying equipment for earth fault protection, there are earth fault relay it can be used. Okay, for oil as well as internal protection of the transformer, we are using a SF6 circuit breaker. Okay, so there are different types of protecting relaying equipment. So for that condition, the coordination of this relaying equipment it will be proper. The relaying equipment's coordination जे असेल ते काय असेल, proper असेल. See, I will tell one of the example of that means protection equipment, or it may be protecting. Suppose one of the line is there, it is having and one of the transformer is there. इथे एखादा transformer आहे, consider करा. So see, on that line the transformer, before and after the transformer there is one of the circuit breaker it can be provided. इथे एक circuit breaker असतो. Again here it is one of the circuit breaker is there. Suppose this line it can be taken from a bus bar. Bus bar कडून supply घेतलेला आहे, एक transformer connect केलेला आहे. After that transformer, here are some of the feeders are provided and it is connected to the distribution transformer. Distribution transformer ला ते काय केले, connect केले. So again here it is switchgear equipment, circuit breaker is there. Here it is one of the circuit breaker is there. Here it is one of the circuit breaker is there. Okay, see, see, the protection it will be applied like that. If any one of the protection it will be fails to act, consider करा एखादा fault झालेला आहे आणि at that situation the fault it will be comes on that area, ज्या एरिया मध्ये तो फॉल्ट येतोय तिथला सर्किट ब्रेकर अनफॉर्च्युनेटली ऍक्ट नाही झाला, that means it will not able to protect, then there is a some of the backup protection it can be provided. लक्ष देते का what I am telling? Suppose actually suppose any one of the fault it will be occur in this point. Okay, या पॉइंटला एखादा फॉल्ट काय झालेला occur झालेला. Okay, suppose here it is line to ground fault it can be occur. So see, the circuit breaker nearer to that of fault, त्या फॉल्टच्या जो काही near circuit breaker आहे, firstly it will act. If unfortunately that circuit breaker it will be fails to act, तो act होण्याला जर fail झाला, then there is a some of the backup protection, it can be also there. Chala backup protection असतं. Always each and every equipment in the power system, there are zone of protection. It can be divided into zone of protection, primary zone, secondary zone, and there are two types of protection. One is the primary protection, second one is that backup protection. Primary protection जर fail झालं, unfortunately if the primary protection fails to act, then to avoid damage to that of equipment, damage to that of apparatus in that power system, there is always backup protection. जर हा सर्किट ब्रेकर फेल झाला ऑपरेट होण्याला, then there is some of the backup circuit breaker it can be used. So this circuit breaker, it will trip the circuit and it will avoid the damage, or it may be it will isolate the faulty part from the healthy part. फॉल्टी पार्ट पासून जो काय हेल्दी पार्ट आहे तो काय केला जातो, आयसोलेट केला जातो. ओके, सो सी, so that means there is a coordination of this relaying equipment or switchgear equipment. Switchgear equipment च coordination आहे. If the coordination is not there, somewhat if any fault it will be occur, and then backup protection it will not act. So then the equipment which are connected in the power system, it may damage, or it may be somewhat huge loss it can be done. Okay, so that the coordination it will be important in case of power system protection. Okay, see, protecting device, and it is very important design consideration. It is the very important design consideration. Now next one advantages is that the neutral of star grounded is sometimes referred to as a grounding bank. Okay, see, the neutral of the star grounded is sometimes referred to as a grounding bank because it provides a local source of ground current at the secondary that is isolated from the primary circuit. There are multiple transformer on the distribution side. That means a 3-phase 4-wire system. 3-phase 4-wire system la multiple transformer astil. So neutral of each and every transformer, it is grounded. So it will act as a grounding of one bank. It will act as a bank because it will provide a local source of grounding. ज्या condition ला किंवा जिथं ground करतो, it will provide a local source ground current, and this current secondary it will isolate from the primary circuit. Secondary काय आहे, primary circuit पासून ते काय करेल, isolate करेल because of grounding. Okay, so these are the advantages of these types of connection, that is delta star connection. Now harmonic separation is there. So we are discussing regarding harmonic, third harmonic. So this will harmonic component, it will, if the harmonic component it will be present in the system, somewhat it will be distortion, it will be occur. Due to that distortion, there is a voltage fluctuation is there, there is a unbalancing is there is a unequal current distribution is there, lots of effect on the power system due to harmonics. Harmonic separation, the magnetizing current must contain odd harmonic. जो काय magnetizing current आहे, this magnetizing current it will contain a odd harmonic component. Odd meaning of odd is nothing but odd harmonic component, that is third harmonic, fifth harmonic, seventh harmonic, or it may be ninth harmonic, like that. So odd number of harmonic. Always magnetizing component it will contain a odd harmonic. So due to that odd harmonic component, for the induced voltage to be sinusoidal, and the third harmonic is dominant harmonic component. याच्यामधला जो काय third harmonic आहे, it is the dominant harmonic component. In a 3-phase system, the third harmonic current of all 3 phases are in phase. 3-phase system मध्ये हा जो काय third harmonic component असेल, due to magnetizing inrush current, or it may be magnetizing current, it will be same in the all phase with each other because they are zero sequence current. Zero sequence current is nothing but we can represent that current IA0. It is nothing but sum of all the current I1 plus I2 plus I3, it is equals to 0, or total current flowing in the each and every phase is equals to 0 according to Kirchhoff's law. Similar to that, in the star-star connection, the only path for third harmonic current is through the neutral. Third harmonic current चा path जो काय आहे, it is only through the neutral. In the delta star connection, However, the third harmonic current, being equal in amplitude and in phase with each other, are able to circulate around the path formed by the delta connected winding. Okay, so star connection मध्ये third harmonic current, it is equals to the amplitude, equal in amplitude as well as phase with each other. So it will circulate or it will create one path which is formed in the delta connected winding, and the same thing is true for other zero sequence harmonic. Other जे काय zero sequence harmonic असतील त्याच्यासाठी same things it will be applied. Okay, now next advantages is that the grounding bank, as I have told earlier, it will provide a local source grounding current at the secondary side, and due to that current it will be isolated from the primary circuit if any fault occur. एखादा fault occur झाला की due to grounding bank it will be act. So due to that grounding bank it will provide isolation between the primary and secondary मध्ये isolation provide करेल. For suppose an ungrounded generator supplies a simple radial system through delta star transformer with grounded neutral at secondary, so the generator can supply a single phase to neutral load through the grounded star transformer. Okay, see, suppose ekada generator, if any one of the generator, it will supply a simple radial system. So generator, it can be connected in parallel and it will supply a radial power system. Radial power system is nothing but radial connection, or it may be a ring type distribution, or it may be radial. As I have told, suppose here it is one of the generator, it will be provided ekada इथं generator आहे, it will be here, it is power transformer, it will feeds to supply to one of the bus bar. On the bus bar there are two feeder, that means feeder 1, here it is another one, feeder 2. Okay, इथं feeder 1 आहे, feeder 2 आहे. Again from that feeder some of the it is transmitted to a long distance. At the long distance there is another one bus bar is there, and again there is one of the output substation, or it may be substation is there. It can be provided to some of the consumer ला काय केलेलं आहे, provide केलेलं. So like that, this is for one generator. Again another one generator on the other side, इकडे एक generator आहे. Again here it is one of the power system is there, it is connected to bus bar. Again it is transmitted and provided to the same load. So it is one type of radial connection system or a radial power system. If any one of the generator it is not grounded, एखादा generator या operation मधला ground केलेला नाहीये, okay, ungrounded generator, so it will supply a current or it may be voltage to that of radial system through delta star connection. Okay, and if grounded neutral at the secondary, so the generator can supply a single phase to neutral load. Then also generator it will be supply a single phase to neutral load through the grounded star transformer. जो star side चा transformer ground केलेला आहे, so that it will provide phase to neutral connection, that means single phase connection also. Okay, so these are the some of the advantages of these types of connection, that is delta star connection. Now there are some of the disadvantages of these types of connection is that delta star connection ची काही disadvantages आहेत. So in that first one, in these types of connection, the secondary voltage is not in phase with the primary. आहे का phase मध्ये primary च्या? Whether it is in phase or out of phase, secondary voltage, whether it is in phase with that of primary voltage or somewhat angle is there. Give me reply. I am asking one question. Secondary voltage, that is, suppose we consider a VA. This VA, whether it is in phase with that of primary voltage VA or there are some of the angle. Give me reply immediately.
Not in phase.
Not in phase. So there is a somewhat angle between that, that is there is a 30-degree angle, plus 30 degree, or it may be minus 30 degree, that is lagging phase displacement, or it may be leading phase displacement. So due to that phase displacement, phase displacement, hence it is not possible to operate this connection in parallel. Okay, so that it is not possible to operate these types of connection in parallel with these types of transformer, that is star star connected and delta delta connected. जर त्या सिस्टीम मध्ये काही ट्रान्सफॉर्मर आपण स्टार स्टार कनेक्ट केले असतील किंवा डेल्टा डेल्टा कनेक्ट केले असतील, so such types of connection and that transformer it is not parallel. Suppose in the power system there are 5 transformer is there, 5 transformer आहेत असं कन्सिडर करा. One is transformer here, another one is here, next one is here, fourth one is here, and fifth one is here. See, in case of these types of transformer, in that suppose 3 transformer are connected in delta star. हे जे काही 3 transformer आहे, this is connected in delta star, this one is connected in delta star, this one is connected in delta star. Suppose this transformer it can be connected in delta delta, it is connected in star star. Okay, see, and suppose these 3 transformer are operated in parallel and I want to add one of the extra transformer in parallel. मला एखादा ट्रान्सफॉर्मर पॅरल मध्ये काय करायचं, कनेक्ट करायचं. सो इन बिटवीन दॅट 2, या 2 ट्रान्सफॉर्मर मधला एक ट्रान्सफॉर्मर मला पॅरल मध्ये कनेक्ट करायचं. सो ऍट दॅट सिच्युएशन it is not possible to do the parallel connection because these are connected in delta star having an plus 30 degree or it may be minus 30 degree phase displacement. त्याच्यामध्ये काय आहे, फेज व्होल्टेज मध्ये सेकंडरीच्या आणि प्रायमरीच्या 30 डिग्री फेज डिस्प्लेसमेंट आहे. सो दॅट वी आर नॉट एबल टू ऑपरेट these ट्रान्सफॉर्मर, दिस वन अँड दिस वन, इन पॅरलल विथ दॅट कनेक्शन. या कनेक्शनच्या पॅरल मध्ये आपण ऑपरेट करू शकत नाहीये. गेटिंग? लक्षात आलं? हॅलो, हा, गेटिंग? नो?
Yes.
Okay, see this problem, one problem associated with this connection, it can be associated with this connection is that the secondary voltage is shifted by not a 300, here it is 30 degree with respect to the primary voltage. This can cause problem when paralleling. ज्यावेळेस parallel operation करतोय त्यावेळेस it will cause a problem while paralleling 3-phase transformer, since transformer secondary voltage must in phase to be parallel. Secondary transformer जे काय secondary voltage आहे ते in phase मध्ये पाहिजे. Okay, now last one disadvantage is that if the secondary of the transformer should be parallel with the secondary of the another transformer without phase shift, there would be a problem. जर आपण तरी ट्रान्सफॉर्मरचं पॅरल ऑपरेशन केलं, then there will be some of the problem it can be occur. So these are the some of the disadvantages of these types of connection, that is delta star having an 1 and 30 degree 1 and 11, that means plus 30 degree and minus 30 degree phase displacement, plus 30 degree and minus 30 degree phase displacement. Now we will discuss regarding application of these types of connection. Commonly used in the step up transformer. For step up transformer, these types of connection is commonly used as, for example, at the beginning of the transmission line, beginning of HT transmission line. What is mean by HT? What is the long form of HT? Can anyone? What is the long form of HT? You in your home, you people are having an your electricity bill. इलेक्ट्रिसिटी बिल जे आहे तुमचं त्याच्यावरती लिहिलेलं असतं बघा, यू आर द LT कंझ्युमर or it may be HT consumer. What is mean by LT and what is mean by HT? Long form of LT and HT. इलेक्ट्रिसिटी बिल असेल तुमच्याकडे तर तुम्ही त्याच्यामध्ये बघू शकता यू आर ॲज अ LT कंझ्युमर असं म्हटलेलं असतं, बिकॉज आवर डोमेस्टिक लोड हॅव्हिंग एन LT कंझ्युमर. And what is mean by HT and LT long form?
High tension or low
High
tension.
tension and low tension. So our domestic appliances, it will require low voltage minimum consumption, so we can call it as a LT consumer, that is low tension consumer. Tension is again nothing but a voltage, high voltage and low voltage. So HT is nothing but high tension. So some industry it will require 11 kVA, 33 kVA, or it may be 66 kVA. So it is these are comes under HT consumer. Okay, so if at the beginning of this HT transmission line च्या beginning la, in the case of neutral point is stable and will not float in case of unbalanced loading. So there is a no distortion of flux because existence of delta connection. It will allow a path for the third harmonic component. Baga, see, at the generator station, generator नंतर जो transformer असतो, it is nothing but power transformer. Okay, after power transformer, one of the switchyard is there. Here it is substation is there. This power transformer, it will be step up the voltage. हे काय करेल, voltage step up करेल. It will be transmitted to over a long distance, and it is here. It is one of the consumer is there. Okay, काही consumer असतील, somewhat having an HT consumer, somewhat having an LT consumer. At the starting of HT consumer, so to step up this voltage, whether it may be 11 kV to 22 kV, or it may be 22 kV to 33 kV. So for step upping this voltage, this transformer it is generally used, because due to that star connection is secondary side la star connection ahe, it is a neutral stable point and it will not float in case of unbalanced loading. जर unbalanced loading झालं त्या HT कंझ्युमरचं किंवा HT साइडचं, if there is a not unbalanced, so at that situation there is a flux distortion, no flux distortion due to delta connected primary side त्याची delta connected आहे, so that there is a no flux distortion because existence of delta connection. It will allow one path for third harmonic component. Third harmonic component साठी तो काय करेल, एक path allow करेल. The line voltage ratio is √3 times that of transformation turns ratio. Line voltage चा जो काही ratio आहे, it will be √3 times that of transformation ratio. And the secondary voltage leads the primary one by 30 degree. In a recent year, this arrangement has become very popular distribution system as it provide a 3-phase 4-wire system. हे 3-phase 4-wire system साठी use करतो. So it will having an some of the popular type of connection. Okay, now commonly used, see here the application come, that is commonly used in the commercial, industrial and the high density residential location. कुठे यूज करतो आपण, commercial purpose, that means my commercial or it may be agriculture field. Industrial, somewhat industrial, it is having a single phase load as well as 3-phase load. Okay, so industrial purpose. And the high density residential location, जे काय residential location आहे तिथे यूज करतो. So to supply 3-phase distribution system, an example would be distribution, it would be a distribution transformer with a delta primary running on 11 kV phases with no neutral, or the earth with no neutral or earth required, and a star or secondary, that is Y connection, it will provide a 3-phase supply. Star connection or it may be Y connection, it will provide a 3-phase supply at 400 volt. It will provide a 3-phase supply at a 400 volt. Okay, and with the domestic voltage of 230 volt is also available, that means single phase 230, 3-phase 440 available between each phase and neutral as well as earth neutral point. So this is one of the application. Now next one, that is last one application, is that used as a generator transformer. Okay, it will be used as a generator transformer. So see, the delta star connection is used universally for connecting generator to the transmission system. Okay, so delta star transformer, it can be generally used universally for connecting generator to the transmission system. Generator जर ट्रान्समिशन सिस्टीमला कनेक्ट करायचं असेल, सो युनिव्हर्सली इट इज कनेक्टेड इन डेल्टा स्टार. Okay, so these are the application of these types of connection, that is delta star 1 and delta star 11. Okay, so these are the one type of connection. We have discussed the delta delta 0 and 6, star star 0 and 6, delta star 1 and 11 today discuss, and star delta 1 and 11. So in the yesterday's class discussed. Okay, so these are the some of the most important type of connection we have discussed. The last one type of connection, that is zigzag connection. Okay, so zigzag connection, in that star zigzag connection and delta zigzag connection. So these types of connection we will discuss in the tomorrow's lecture. So in this way we will conclude this today's lecture and we will stop here. Is there any doubt in this connection? याच्यामध्ये कोणाला काही डाऊट आहे का? Any doubt? Give me reply immediately. Is there any doubt?
No, sir.
Okay, so in this way we will conclude and stop here. Thank you.